What do I do when you're integrating the i's? When you're integrating, the powers increase if it's a polynomial. So the powers increase for this, the powers don't increase for that because it's not a polynomial, it's an exponential. The powers don't increase for that because it's a trig question. The powers do increase because it's a polynomial. So go back to this one. I write the same thing down, that's all my brain thinks. There's another teaching method and people teach it completely different. Well, it's not completely different, it's a variation of this. All I do is increase the power of the 4 and divide by the power of 4 plus c, and I've forgotten something. What have I forgotten?
Times by the inside.
Times by the derivative of the inside.
So it's 4x.
4x. And there's the question though. The rest you can tidy up. Only works, Jamin, because the
X is cancelled.
and I've got 2x squared minus 1 to the 4 and 16 plus c. Some people like to factorise it first and then do it, but in the long run, once you get the hang of it, you can just do this. So the next question. Oh, what made it work? That the outside had a power, an index of 1 less than the inside. So go to this one. Where is the inside on an exponential? That's actually got a bracket. That's actually got a bracket. So we're talking about, that's the inside. So what happens with an exponential? The rule, it is all stays the same. Divide by what?
2x. No,
Divide by the derivative of the inside, which is a 2x. Did I increase the power by 1 like I did here for a polynomial? No. This was a polynomial, this is a exponential with a polynomial inside of it, but it's just an exponential. So how do you do an exponential question? It stays the same. The 4x stayed there. Divide by the derivative of the inside, which, you know, I arrow to and do all sorts of stuff, 2x. So it happens that x cancels. If it doesn't cancel, you've got the wrong method for the question. That becomes 2e to the x squared plus 1 plus c. By the way, if you wanted to check it, no, let that be y equals. What's the derivative of it? How do you differentiate an exponential? Stays the same. Times the derivative of the inside. What happens to the c when you differentiate it? Becomes 0. And we've got 4x e to the x squared plus 1. We're back to where we started. So does it work? Yes. Next one. Where's the cos come from? So is this a polynomial? It's got a polynomial inside. Is it a polynomial question like that? No. Is it an exponential question like that? No. Is it a sine cos tan question? Cos comes from sine. So what's really going to write? That stays the same, that's a sine, and that stays the same. Did anything change? Well, one thing, this cos became a sine. Sine will give us a cos, so we don't have to worry about the negatives. I need plus a c. What have I forgotten?
Divided by x.
So the derivative of the inside reverses the process from what we did before, and they cancel, and I've just got sine of 2x squared plus 3, which is so easy to check if it's right. If I differentiate that, sine becomes a cos of the same thing, times by the derivative of the inside, which is a 4x. Question's done. Okay? So when I've tested kids and I have some of them do this method and some do the other method, this is just so much more successful than the other one. So what have I got now? I'm back to a simple polynomial. You can do that yourself in a second. An exponential, a bit more complicated. It's got an x cubed, which becomes an x squared. This one, can I do this one using this method? No, because that's got an x to the power of 1 and that's got an x to the power of 1. What's my only choice for this question? Expand. So I've got to deal with this as 2x outside of 9x squared plus 6x plus 1. Can you follow me that quick what I just did? 3x by 3x and 3x by 1 and 1 by 3x. So I've done all that. So it's actually the integral of 18x cubed plus 12x squared plus 2x. So that is actually just a cubic. Can I differentiate a cubic? Of course I can. Can I differentiate a cubic in that form? No. So what was this one? That's an x squared with an x cubed to x to the 6. That's an x to the 7. So what's that? I don't know. So septic. I don't know what that polynomial function is. A polynomial function with a power of 7, a degree of 7. So do the other couple. Oh, I think Riley come from. Come on, Riley. Tell me how to do number 4, so you can all sit there and just watch. How do I get the end of all that?
You raise the power by 1,
Yeah,
and you divide by the derivative inside.
yeah. Move the inside is 30x squared. What have I forgotten? Divide also by the
Power.
power.
Oh, it's 5 of them.
Don't forget the plus c. So I divide by the derivative of that, and I divide by the power. Yeah, okay? You see it on your head, then you tidy it up. 5 cancels, x squared cancels, and I've got 1/30 of 10x cubed plus 3 to the 5 plus c. If you reverse the process, you'll see it works out. Yeah? Riley, another one then? What have I got?
You have to just divide by the derivative inside, which is,
Good. Now, see I put the extra brackets in?
doesn't really do anything.
No, so I didn't need to have that, I don't need the brackets there.
Oh.
So my first thing when I see these is it stays the same.
It's just divided by x squared.
Yeah, so it stayed the same, divided by 3x squared. There's nothing else to divide by. Don't divide by the power because it's not a polynomial, it's an exponential function.
So it's just
Plus C,
2/3 of b.
questions done?
Wait, I thought you did like the full thing.
You don't need to.
Nah, that's it. So the answer is just 2/3 of e to the x cubed plus 3 plus c. If I reverse the process, Ray, so the 3 will cancel with that and I'll be left with a 2x squared and that stays the same. Questions done?